It's a real pleasure for me, on behalf of Université PSL, to greet our audience and our distinguished guests for this webinar organized in partnership with New York University. I am Emilienne Baneth, Vice President for International Relations and International Partnerships for the SDGs at Université PSL. This is the first in a series of conversations we would like to sustain with our partner universities around the world on critical issues and challenges which researchers and students are actively addressing globally and which are at the core of Université PSL's priorities. These issues are of a complex and global nature, so they can only be approached through interdisciplinary and international cooperation. So our intention in crafting this cycle around some of the United Nations' most prominent international days, which periodically highlight human and environmental challenges, is to open a platform for discussion across the boundaries of space and disciplinary specializations. So I sincerely thank Professor Joseph LeDoux, New York University, for being here, Professor Dominique Lestel, École normale supérieure-PSL, for joining us, I hope soon, to engage in this first dialogue. So after their 20 to 25-minute position speeches, they will enter a conversation moderated by Professor Phillip Usher, New York University. And I thank you as well, Phillip, for being here. This conversation will then be opened to questions from the audience in the last 20 to 30 minutes of our session, which will end at 7:30 Paris time, 1:30 p.m. New York time. I would like to ask the audience to place questions through the Q&A thread, please, rather than through the chat. It makes it easier for us to monitor them. Our moderator is Professor Philip John Usher from New York University. Professor Usher is a scholar of comparative and French language literature at NYU, where he is also chair of the Department of French Literature, Thought and Culture. His research, though, is increasingly situated at the crossroads of early modern studies and contemporary theory, with a particular emphasis on classical reception and the conceptual histories of cartography and ecological thought. His latest monograph is entitled Exterranean: Ecologies of Extraction in the Humanist Anthropocene. Professor Usher, the floor is yours.
Thank you. Good morning or good evening to everybody who's here, and welcome to Reflections on Human Life on Earth, from our deep history to the post-Anthropocene. And first of all, happy Earth Day. So it's my distinct pleasure to be moderating our event today, co-organized by PSL and NYU. And I'm particularly excited to be here because I think whatever our disciplines, whether we're in the sciences, the social sciences, or the humanities, we're all starting, if we weren't already, to think in much bigger timeframes. Disciplines that didn't look into the deep past or into the distant future are now invited to do just that, which is in turn opening up new interdisciplinary connections and constellations. I'm a literary scholar who grew up doing human-focused close readings of Flaubert and Montaigne. But in my last book, I ended up talking not just about poems and architecture, but about the very old history of what would become Normandy, reaching back to a time when it was essentially a giant mangrove inhabited by crocodiles. As Dipesh Chakrabarty has argued so coherently and convincingly, history and geohistory, natural history and human history have caught up with each other. And I think few disciplines can skirt around this new reality. Today, it's particularly interesting, I think, that we have two speakers from quite different disciplines who can come together around a table to discuss such questions. I think it could be interesting in the discussion to think about how disciplinarity and its ongoing reconfiguration relates to timescales of thought. How is a professor of neuroscience, for example, invited to think differently in the Anthropocene? How is a professor of philosophy called upon to take into his thinking such vast swaths of time? So allow me to introduce our speakers today. Joseph LeDoux is professor of neuroscience and professor of psychiatry at NYU. He is a university professor and directs the Emotional Brain Institute at NYU. His work focuses on the brain mechanisms of emotion, memory, and consciousness. He has received a number of awards for research and is an elected member of the American Academy of Arts and Sciences and the National Academy of Sciences in the US. He is also the author of several books, including The Emotional Brain, Synaptic Self, Anxious, and The Deep History of Ourselves. As a sideline, he is the lead singer and songwriter in the rock band The Amygdaloids and in the acoustic duo So We Are. Dominique Lestel, our second speaker, is professor of philosophy at the École normale supérieure-PSL in Paris, France. Professor Lestel's philosophical work has been significant in recent efforts to rethink animality and human-animal relations. He is the author of many works, including the much reviewed and discussed Eat That Book, A Carnivore's Manifesto, which came out from Columbia in 2016. He has notably taught and researched at MIT, UC San Diego, Boston University, the School of the Art Institute of Chicago, the University of Tokyo, and the University of Keio, also in Japan. Our two speakers, one a professor of neuroscience and psychiatry, the other a philosopher, have a lot to say today about the human, about human life, about non-human life in the longue durée, from past's past to future's future. We'll be hearing and talking about the limits of the human, of human and non-human relationships to time, to technology, and to ourselves. So please go ahead as you're listening to our talks and put questions into the Q&A, as was already mentioned, not into the chat, the Q&A, that's slightly different, indicating to whom they're addressed. And feel free to write in English or French. We'll read them out and translate if necessary. So thank you everyone for being here, and over to you, Joe.
Okay, I'm gonna share my screen here, if that works. Let's see. Host disable. The screen sharing is disabled, so we need to turn that on. Okay, here we go. Great. Thank you, Philip. Thank you, Emilienne. It was, it's so nice to see you again after all these years when you were in New York. So I'm going to talk about, but before I start, I want to thank Philip for saying something which helps clarify something in my past, which is I didn't know that there were crocodiles in Normandy. And I think that a lot of my LeDoux ancestors came from Normandy and went to Louisiana, where they found the familiar alligator instead of the crocodile. So maybe that has something to do with something, I don't know. But today we're going to talk about a different kind of history, the deep history of ourselves. And I'm going to start with this idea from Ralph Waldo Emerson that as soon as there is life, there's danger. And this all comes from the book that was just mentioned, 4 billion year story of how we got conscious brains. And so here are the 4 billion years, the first 3 billion shown across the top here. So we had these like biological experiments, and then at some point, a life form that was able to survive long enough to duplicate itself, and in other words, to reproduce, and then give rise to other organisms. This is the beginning of the history of life. So some bacterial cell, billions of years ago, split in half, lived long enough, and then kept splitting in half and kept splitting in half. It's been said that every bacterial cell alive today is the daughter of that original bacterial cell that first split apart. Anyway, we go across all these billions of years from all these are unicellular organisms for the first 3 billion years or so. And then in about 900 million years ago, we're shifting to millions on the bottom scale here. Plants living in the ocean floor came along. These are multicellular organisms as opposed to unicellular. That means all the cells in the body are devoted to keeping that body alive. In unicellular organisms, they sometimes come together as colonies, but any one can defect and live off by itself. But a cell in your body cannot live on its own in the outside world because it's dependent on all the other cells in the body, just like in every other multicellular organism. The first animals came along in about 800 million years ago. These were sponges or sponge-like organisms. And then came jellyfish-like organisms. But the bilateral invertebrates were the first organisms to have a left, right, front, back, and a top, bottom. So they're bilaterally symmetric. Jellyfish have a top and a bottom, but not a left, right, and a front, back. And that's important because it means the body plans that followed in most of the rest of life had this organization where there's a set of sensory structures in the front, a brain that is able to process all that sensory information efficiently and to send commands to the rest of the body so that the whole body can move as a unit. So the first vertebrates, the first animals like us, were jawless fish, and then jawed fish, and then came amphibians, reptiles, mammals. We're primates, and we're humans. So that's kind of the 4 billion year story of our history. But why did I write a book about this? Because this is not exactly up my alley in terms of this kind of biological history, and I had to learn a lot of it. Well, it has to do with, I worked on the topic of how the brain detects and responds to danger for a long time. Instead of calling that fear, because I've been working in animals, I prefer to call it threat and defense, since it doesn't make any assumptions about the subjective state of the animal, which is hard to know. And we've learned a lot about the neural circuitry underlying this kind of learning and behavior, responding to danger. This part of the brain we call the amygdala is crucial. It integrates all the sensory information from the world, puts that into a representation that can then control our body responses and release all kinds of chemicals like norepinephrine and acetylcholine and serotonin throughout our brain to keep things aroused in a dangerous situation. So what do you do after you know something about the circuit? Well, the standard thing you do in neuroscience is you look for the cells and the molecules in the circuit that explain what the circuit is doing. Now, what's interesting is that both invertebrates like us, that includes rats and snakes and fish and all those animals I mentioned, both invertebrates and in the invertebrates like bugs and slugs and flies and crabs and worms and all those things, even though they have different circuits, the same molecules are involved in learning about danger. Now, that's kind of interesting, because what it means is that if we go back to the history of life, here we have on this side the vertebrates and on this side the invertebrates. In order for these two groups to have the same molecules mediating their learning, means that they had to have a common ancestor that provided them with the genes that make those molecules. So the common ancestor of these groups was that flatworm that I mentioned, that bilateral flatworm that existed about 630 million years ago. So here we have the vertebrates, here we have the invertebrates, here's that common ancestor. Now, that common ancestor shared a common ancestor with jellyfish about 700 million years ago. And these jellyfish-like organisms had a common ancestor with sponges about 800 million years ago. And all these animals have some of these same molecules and genes that underlie learning. But so do single-cell protozoa, these chanoflagellates. Now, it turns out that unicellular protozoa and bacteria behave despite not having a nervous system. You don't need a nervous system to behave. You don't even need it to learn. So bacteria and protozoa can be swimming along in the world, and they see something come in, their membrane detects something that's useful to them, like some kind of plant material near the surface of the water here. And so they move in that direction. They approach where there's something good. And if they're swimming along on the bottom here and they hit something that's toxic or repellent, they turn away. So they exhibit approach and avoidance, and they also can learn to approach things that are useful to them and avoid things that are harmful to them that they've acquired through experience. So behavior and learning do not require a nervous system, and in fact are as old as life. They exist to keep the organism alive, not to, when we think about our behavior and so forth, we think of, well, we avoid pain because we have these feelings of pain, or we approach food because we're hungry, or we run from the bear because we're afraid. But these are projections onto behavior about internal mental states about which we know very little in other animals. This doesn't mean they don't have those states. It just means that it's very hard to approach that as a scientific question. But anyway, the idea is that behavior didn't arise and persist for psychological reasons. It's simply part of the organism's survival toolkit. That first cell had to be able to detect danger to stay alive long enough to reproduce and give rise to the rest of the history of life. So what are the requirements of a cell? Well, they have to make energy, balance fluids and ions, withdraw from harmful agents, and reproduce. What does a person have to do? And what does a person species have to do? Make energy, balance fluids, withdraw from harmful agents, reproduce. The requirements of life are the same, regardless of whether you're, a bacterial cell or a complex mammal or even a human. Now, the way we solve our problems of survival are very different from the way bacteria do it, but we have to solve the same problems. So we have different implementations because we have different bodies. The history of evolution is the history of how bodies changed over the long course of time. And each time a new body comes along, it's because some members of the species have branched out into a new environment or something like that. And the conditions for survival are no longer what they were for the older species. So a new species with new features, the organisms with the features that are good for the new environment are going to become more plentiful in that environment. And that's just kind of the way evolution works. So body plans change, and went from different kinds of unicellular organisms to finally multicellular organisms and different kinds of multicellular organisms, all because the environment in which these organisms were evolving put certain demands on the body plan that would allow them to survive. So we can think of our survival responses, for example, our ability to detect danger and to run away from danger or to freeze in danger, as really just a direct manifestation of this long history that started billions and billions of years ago. And we can follow that all the way through. I mean, all these animals that we're looking at will detect and respond to danger, but a jellyfish will collapse its umbrella, basically close up things where the food and stuff in the mouth is at the bottom, and then they can kind of dart away from danger. Fish, on the other hand, can actually swim away. Amphibians can swim or walk on land. Reptiles can do all kinds of things. Some fly, some run. Mammals, we can fly, we can run, we can swim, depending on what kind of animal we are. So the body determines how you deal with danger, but the fact that you have to deal with danger is universal. Now, one problem is that as I started to say a minute ago, we project our emotions onto other organisms on the basis of their analogy with our behavior. If we're running from danger, we're usually feeling afraid. Therefore, if a rat or a mouse or a fish is swimming or running away from danger, it must be because it's afraid. But that's a logical flaw, because as it turns out in the brain, the feeling of fear, the conscious feeling of fear, is not coming out of the same part of the brain that is producing the behavioral responses. The amygdala, my friend, the amygdala that I've worked on so long, is responsible for the behavioral responses, but the conscious feeling of fear is something different. Let's see how we're doing with time. I wanted to, how much time do I have?
Good. Sorry, go ahead, Emily.
Yeah, you have some time, because we had news of Dominique Lestel, who has technical difficulties, and he's probably going to be joining us in 10-15 minutes. So you definitely have 15 or 20 minutes, no problem.
Good. So then I'll play a song. This is
Oh, good.
Sometimes when I write these books, I write a short album that goes with them. And this book, The Deep History of Ourselves, has a little album called Songs of Life with it. And this first song is from the Emerson poem, as soon as there, let's see if I can get back there. As soon as there was life, there was danger. I wrote a song about that. And you'll hear kind of it'll start out and then there'll be a bit thunderclap. That's meant to be the beginning of life. So this is kind of like the whole history of life, if I can get my computer to work. Okay. Okay, one more try. Here we go. Nope. Maybe that's not going to happen. Happened yesterday. Okay, well, last try. Okay, no music. All right, so let's move on. Try again at the end of the talk, maybe. So, through these studies, of these behavioral and physiological responses, this is by threat, the amygdala has become known as the brain's fear center. This is something my work is partly responsible for, but something I don't necessarily endorse. And in fact, I don't endorse. So I've been trying to make clear exactly what my views are. I've always thought of the amygdala as an unconscious detector of danger. And so we called it a kind of implicit or unconscious fear circuit, but no one processed that adjective, the unconscious part. It just became the fear circuit. And I became known as the person who had said that the amygdala makes us feel afraid. And all my lectures would be, I'd be introduced in that way as having found how the feeling of fear comes out of the amygdala. And there were other people who actually claimed that that was true. So it became kind of a controversial issue. So what's wrong with the amygdala fear center idea? Well, behavioral and physiological responses don't always correlate strongly with subjectively experienced fear. You can be running from the bear, but your heart is not necessarily racing, or your heart can be racing in danger, but you're not necessarily that afraid. This should all go together if they're all products of fear in the amygdala. The threat turns on the amygdala feels fear, and that makes you run away according to the standard story, but that's not really what's going on. Number two, there are ways you can present stimuli to people non-consciously, in other words, subliminally, and the person won't know the stimulus is present. And yet, if you have the person in an imaging machine, you can see that their amygdala is activated by the stimulus. Their heart rate is beating, their palms are sweating, but they not only don't see the stimulus, but you say, do you feel anything? They don't say, I feel fear or anything else. So you don't need fear to activate the amygdala, and you don't need fear for the amygdala to produce the responses. Number three, damage to the amygdala interferes with the ability of the threat to elicit the responses, but doesn't necessarily eliminate these feelings of fear. So there are a lot of problems with this whole idea about the amygdala. So I wrote a paper in 2012 called Rethinking the Emotional Brain about all this. And this is on top is the fear center view. The threat sensory system activates the amygdala, fear is experienced there, and the fear causes the behavior. And then I offered a different view, a defensive survival circuit idea, where the threat activates the sensory system activates a defensive survival circuit. In other words, taking fear out of this thing and just simply letting the circuit detect and control the responses. Now, these survival circuits, all vertebrate animals have a survival circuit like this, and all vertebrate animals have an amygdala that does this. All of the invertebrate animals have nervous systems, and they have these survival circuits as well. They don't have an amygdala, but they have their own survival circuit. And if you follow this logic, then if you're going to make the survival circuit about fear, then you're going to have to say that the reason a worm squiggles when you're putting it on the hook is because it's afraid of what's going to happen. Or the fact that a bacteria moves away from danger is because it's afraid, because we're talking about the same thing, a long history of life that allows organisms to detect and respond to danger. And I don't think that that's why the bacteria turns away from danger. It has something, its membrane detects that there's something harmful, and that's just how it's built to move away. It doesn't mean that other animals don't have fear, but it's not the kind of fear we have, as I'll explain. So why does it matter what we call things like this? What do we, like this circuit? What's the big deal? Well, in physics, physicists talk about quarks, kind of particle, sorry. Oh, sorry. This should say in biology, we talk about a gene called hedgehog. And when you do that, nobody thinks that you're talking about the gene has a hedgehog in it, or that the the particle is literally a quark. But when we talk about psychology and neuroscience, we talk about a fear circuit. People think that that's where fear is, because we're talking about projecting our mental states into the brain. And we have to be careful when we do that. Obviously, our mental states come out of the brain, but not necessarily in the way that's intuitively obvious from our behavior, our monitoring of our own behavior. So, you know, there's been a lot written about. I'm not the first person to complain about all of this. Francis Bacon in 1620 said scientists should be vigilant and guard against tacitly granting reality to things simply because we have words for them. Mandler and Kess and a couple of psychologists in the 60s said the common language is full of quasi-psychological assertions, and the language in which these framed is inadequate. Jack Block said psychologists have tended to be sloppy with words. Summary labels and shorthand expressions come to control the way we think. And so that's why we shouldn't be so sloppy. Melvin Marks, there's a semantic danger that results when a common language term is used as a scientific name for an intervening variable or hypothetical construct. The variable or construct becomes infected with the subjective properties of the common meaning. So in the case of fear, the amygdala has become infected with the subjective properties of the concept of fear when fear is not what comes out of the amygdala. Okay, here's a practical example of why this matters. You know, it's not just ivory tower kind of argument about what we should call something. If we look at how drugs are developed, for example, to help people who have problems with fear and anxiety, the history has gone so bad that the big pharmaceutical companies are, you know, bailing out of the whole enterprise of psychiatric drugs because, you know, they've concluded that nothing is, they haven't been able to discover anything since the 1960s, when most of the drugs were discovered accidentally in the process of studying something else. So, you know, the CEO of GlaxoSmithKline said in 2010, the effort has been so disappointing and that we're not going to invest in it anymore because the probability of success is so low. All right, so here's our defensive survival circuit then. What about fear itself? How does it come about? Well, first we want to note that this is how drugs are developed through studies of animals and giving them a drug to make them less behaviorally timid. If the animal is less timid, when you give the drug to the person should feel less fearful because the animal is less fearful because it's been given the drug and its behavior has changed, this timid behavior has changed. But what happens is that I think people are feeling fearful by way of a cognitive circuit that's interpreting the situation in which they find themselves. And if that's the case, then it's not surprising that drugs that change these ancient circuits aren't going to change the content of one subjective experience about how they understand who they are in danger. So I'm not going to go through this whole thing, but we have a lot of things that go into an experience of fear. You know, there's sensory information, there's semantic memory about what the thing is, there's episodic memory about your experiences with that thing. We have our understanding of who we are, which is a self schema. Going on this side, we've got a survival circuit, like a defensive circuit that is activating body responses, activating brain arousal. The survival circuit is also compelling the kind of schemata that are developing through all of this integration on both sides of the clock here into an understanding of who you are, how you respond to danger, what kind of situation you're in, what you can expect, what you can hope for, what's the worst case scenario, what's the best case scenario. All of that is coming together implicitly, and the end result in your mind, perhaps in working memory where we monitor, appraise, and attend to things, have metacognitions about them, introspect about them, and give verbal reports. Fear is the conscious experience that arises out of all of that meta representation of all of that lower level information. So what I'd like to say is that fear is not universal. It's danger that's universal. We hear that, you know, everybody feels fear around the world the same. That's not true. And they don't even express it around the world quite the same. So it's not fear that's universal, it's danger. And to the extent that the expressions have some similarity across the world, it's because of those kind of basic low-level things like the amygdala that control these innate responses, like, you know, facial expressions and freezing and fleeing and so forth. So it's not that we have these innate emotions. What we have are these innate responses that we share around the world. We know that experience varies across cultures. And because we can translate words like fear across cultures, we assume that people worldwide have the same basic experience named by that word. But cultural differences are based on differences in the schema involved. The schema are personal, so the different people within a culture have different schema and different experiences. So animals lacking our kind of cognition can't have our kind of schema and our kind of fear. Doesn't mean they don't have anything, but they don't have what we have, and we shouldn't be projecting our emotions onto them. So what is an emotion? I'm wrapping up here. It's a narrative-driven, subjective experience in a biologically or psychologically significant situation. And again, well, sorry, that doesn't all have to go there. Skip all that. All right. So I want to close out with, where here we are on Earth Day and we're going to be talking about these things. And I think the reason that I was invited to speak to you on Earth Day is probably because of the last paragraph or so of the deep history of ourselves. So I'm just going to summarize a little bit of what the last page or so says. Our conscious capacities have made our greatest achievements as a species, art, literature, music, architecture, science, medicine possible, but also our most troubling and base dispositions: selfishness, narcissism, greed, envy, tribal jingoism, hatred, and evil. These proclivities challenge our ability to coexist within and between social groups, and also threaten the planet and its habitability for our descendants and for other species. Each species we lose to natural causes or to human short-sightedness alters the balance of biological power and ultimately affects our ability to survive as well. If we think about the extinction of the dinosaurs, what's believed to have happened is some climactic condition that made it impossible for them to persist because of their large energy demands. Some of them were quite large, and they needed a lot of power to run that giant machine. What survived instead were the tiny little organisms called mammals at the time that had very low energy needs and were able to persist under very drastic conditions because they lived mostly under the ground and or close to the Earth's surface, and were less affected by the atmospheric changes that affected things out on the open in the surface. So, this is an important lesson to us because currently, if you ask who are the big energy demanding organisms on Earth, that would be us. Now, we're the only species that's ever been able to predict our possible demise. We often hear about we're going to kill the Earth. The Earth's not going to die. It survived billions of years, and there's no indication that it's going to go away. It's going to survive without us in some form. And history tells us that these mass extinction changed the balance of biological power. In other words, the dinosaurs went away. Bacteria are surely going to make it, because they've survived for almost 4 billion years. Whether, who knows, maybe the whole post-Anthropocene life will be started by bacteria and we'll go through another billion years, and who knows what'll come up. I don't think it's going to be that drastic, but certainly the big energy demanding organisms are not necessarily in a great position right now to persist. But it's kind of up to us. Really, we can change things or we can just let them go. Our future is in our hands metaphorically and in our conscious minds literally. We have to change the world consciously. We can't just let it happen. And the only way for that to happen is to find some way that we can cut across, despite the cultural differences, across our differences and have a meeting of the mind, of the conscious minds. Our conscious minds have to collectively agree that we need to do things. We can't just allow, unconscious presuppositions and assumptions and hoping for the best to work. We have to do this ourselves in a willful, intentional way. So that's all from the deep history of ourselves. The book website is deep-history-of-ourselves.com. The No Self, No Fear t-shirt is there under the merch. You have to pay for that, but the music is all there. Sorry we couldn't hear it. There's the t-shirt. And Songs of Life are the songs, as soon as there's life, there's danger. The only question is life itself and what it is to be. And there's one last song. Let's see if this one plays. If not, we'll turn it over.
Joe, I think you have to, at the top of your screen, there must be something that says share computer audio, and you need to click on that for it to work. View options, maybe, if there's
let's see, more. No, I don't see an option. That's okay. You know, people, if they're curious, they can go to the Deep History of Ourselves website. Or maybe during the discussion, I'll try to find it. If we have time, I can play it as an audio file later. Anyway, okay. So let me stop there and turn it back over, I guess, to Philip. Stop sharing my screen. Okay. Thank you very much.
Thank you for that. That was fabulous. I think we're going to have a lot to talk about, and a couple of questions have started to come in. So, but we'll save those for afterwards. So our second speaker, Dominique Lestel, is with us, and I already introduced him at the start of our broadcast today. So I will just stand back and hand over the microphone to Dominique Lestel.
Thank you very much. I wish to beg my pardon because of my late arrival. It was a technical problem. I think that there was, you know, like in Japanese mangas, a ghost in the machine. But no, it should work, and I can give my short talk before discussion. So it will be about post-Anthropocene world and hyperfuture. Today, the notion of post-Anthropocene is a singular subject with awareness that Earth is not only fragile, but is becoming weaker and weaker. Global warming, breakdown of biodiversity, depletion of natural resources, are the three pillars on which that notion puts its legitimacy. I have no technical devices like Joe has shown, because I am a truly French philosopher with an interaction with words in a particular way, words and text. So notion of post-Anthropocene could therefore have three meanings: the after-human world, end of the world for the human, the end of the industrial world as we know it, back to Paleolithic, back to tribal societies, and the world after the human as we know it, post-human. Hyperfuture I'm interested in here is a future that that would begin, let's say, 100,000 years ahead. It sounds very very big, but basically we have to be careful about the fact that this is not really a classical temporal category, because that hyperfuture could begin on tomorrow and even on the next second. So there are a couple of ways to think about hyperfutures, and I wish to begin with the three more widespread scenarios we have now. The first one is the scenario of the end of the world. Everything collapses. The world of the after human, end of the world for humans, has been discussed by a number of contemporary theoreticians. I just give you two names, no more: John Leslie, a Canadian philosopher, and the British astronomer Martin Rees. Both are good options, or are good examples of that options. That approach is nevertheless the less interesting to think. The second scenario, more widespread scenario, is more than the end of the world, the end of this world, a world that would be freed from humans' ecological footprint and would be a breakdown of contemporary hyper-technological civilization with a return to tribal primitive edges, as it has been discussed by French philosopher Raymond Rouillère in An Evolutionary Perspective. In a somewhat strange book he has published in 1977, he tries to know what could be humanity in 10,000 years ahead. In that evolutionary perspective he has taken, he predicted that humans could survive only if they reproduce enough, and that only an ultra-religious patriarchal society could fill the requirement. Thus, he contrasts what he calls contemporary conquerors of space with who are the only ones to be able to develop with conquerors of times, who are the only ones to be able to develop societies that last for a long time. We are living in a society of conqueror of spaces. We are very good at that, but we are very bad to conquer times. The third scenario, the post-human as we know it, the post-human as we know it world, the post-human, is the more widespread option today through the transhumanist movement. Today, pioneers of that movement are largely forgotten. F 2030 or Max More, people who doesn't say anything for you, I guess. But the works have attracted attention of the entrepreneur inventors of the Silicon Valley, like Ray Kurzweil, and it is now a main intellectual and social movement. Its ideology is an ultra-liberal one, often thought through the form it has been given by anarcho-liberalism. But post-humanist theoreticians added to the wish to free themselves from the constraints of the state, the wish to free themselves from the constraints of the species. The posthumanism, in that way, had the goal to promote what was up to now unthinkable, the human after the human. And it therefore opens the perspective of a post-Anthropocene world in which preeminence of humans on Earth has been superseded by other forms of intelligences, technologically modified post-humans by a mixtures, of biotechnologies, nanotechnologies, and information technologies, or post-biological non-human intelligences like super artificial intelligence. But these approaches are far from being the only ones. Both of them refer to a form of realism that is only roughly plausible. Other thinkers, today largely forgotten, at least in Western countries, offer very different visions of hyperfuture. What makes their specificity is that they put religion at the center of their vision of the world. Nikolai Federoff and Pierre de Chardin are quite special in our atheist and materialistic time. Russian thinker Nikolai Federoff, he was at the beginning of the 20th century, used humanity to mobilize itself to carry out what he has called the common task. His idea is to use the more advanced sciences and technologies to raise persons from the dead and to conquer other planets to put these new living persons on them. An end of the history that is very different indeed from Hegel's one. Federoff's project is a crazy one, but it is a long-term project, and it nevertheless already had concrete important consequences. It is, for example, one of its followers, Tsiolkovsky, who is the father of the Soviet space program that has sent out the first human in space, Yuri Gagarin. The trend initiated by Federoff is roughly unknown in Western countries, but it still has a great influence upon some of the most important advisors of Putin. French Jesuit poet, priest, paleoanthropologist, and theologian Teilhard de Chardin has proposed a geological vision of universe by foreseeing a new geological era, the noosphere, in which mind, spirit, in French, esprit means both, has become the main evolutionary force. His hand of history is also very different from Hegel's one, because it is made of the fusion of all humans with God in the so-called omega point, both origin and end of the evolutionary consciousness. Are the three scenarios, the three first scenarios, more plausible than the last two? Basically, no. We usually think that because we used to think that what is reasonable has more chance to occur, but this is wrong and there are good reasons for that. In particular, I wish to deepen two main points. First, one key feature of hyperfuture is that anything could happen, at least from our point of view. A second point is that what will happen will be necessarily very different of what we expect will happen. And this is more likely to be a good news because of the difficulty to rightly conceptualize what is at stake. These points require to be a little bit more explained. I wish to give only two reasons among many for which futures could be anything and will always be very different of what we will have figured out. Optimistic temptation is to think that the situation exists because we have not yet the good methods to grasp the logic of hyperfuture. You know, with that hope that we could have one day the good method to know that future. The pessimistic version is worse. It says that the main reason for which we cannot understand hyperfutures is because anything is possible and that what will actually happen will only very partially depend on what we can do and wish to do. When I said that anything could happen, it means, of course, anything could happen in a possible way. Of course, the pessimistic option is the most attractive for me because the optimistic one is not very interesting, you know. And the pessimistic approach option could be introduced by two thinkers, Henri Bergson and Nassim Taleb. Everybody knows Bergson, the French philosopher, and one of his ideas was that he has shown that future is always invented. Reyer gives a very good evolutionary illustration of that insight. He said that no protozoa could never have figured out elephants, birds, fishes, humans that will be the successors. But we nevertheless, afterwards, draw back the phylogenetic history that have led to the species. Phylogenetic history is always an a posteriori history. Nassim Taleb himself is a trader and a philosopher. Nassim Taleb draws attention about what he calls black swans. These particular events are both highly improbable and deeply disruptive if they appear. If this is that uncertainty is about the moment where it will happen and not about the possibility. I think is still very optimistic. For sure, we will be confronted with one or several such events during the course of our lifetime, because if each of them is highly improbable, the multiplicity makes them very probable. that the probability, the multiplicity makes very probable that at least one occurs in the medium term, and that many of them will appear in the long term. Finally, last but not least, as they are not independent one from the others, knowledge of hyperfuture is actually impossible. The new black swans will appear in the context of the situation created by the old ones. To think hyperfutures, one doesn't limit problems of unexpected events, but also deep difficulties to conceptualize the world, to conceptualize what is at stake. I want to discuss that question through one example, the example of species. One of the very few things that we could be sure about with hyperfuture is that the species Homo sapiens will be deeply transformed. Of course, transhumanists think that such a transformation will be like what they are expecting it will be. Unfortunately for them, and probably for the sake of the other, posthumans will be very different from the dreams of these people for the reasons discussed above. What is more of interest for me here is another important question. What does it mean to belong to a given species? And therefore, what does it really mean to go out of one's own species? The point at stake here is that it's not possible to rightly anticipate phenomenon we don't understand enough. But about that post-humanity, the possible post-humanity, and the possibility to go out of one's own species. A first point is in that nobody could rigorously define what a species is. And I would refer here, for example, to the work of philosopher of science Phillip in particular in a paper of 1984. A second one is that the question of species is not purely a biological phenomenon. Biologists used to say that we belong to one species, but that expression doesn't mean a lot. What interests me here is to understand what it means to inhabit one's own species from the point of view of the first person, and what could be evolution of that situation. An intriguing possibility is that one could be able to become, at least partly, part of another species, or even of other species. It sounds very speculative, I know, but some artists are already on that way. I have in mind, for example, artistic performances, like the one that has been presented by French artist Marion Laval-Janté, when she has received the blood of a horse in her own body, having unexpected and weird feelings after that experience. She felt like being a kind of horse, of course not a horse, but a kind of horse. The question of species exceeds what biologists could say of it or what transhumanists could dream about, and leads to true political, ethical, and metaphysical questions that are still largely unheard. And that problem is a good example of many processes that will be transformed in the future. The question, therefore, is to broaden the field of possibilities and to be ready to think even the most apparently eccentric ones and to prepare oneself for the impossible. That's a really appealing philosophical program. Therefore, a suggestion, a little bit provocative, I confess. Philosophy should become something like a branch of science fiction. Pandemia, we are now living with, has put the world in an extraordinary situation that only writers of science fiction have actually thought. I don't say that philosophers should write science fiction, even if they can, but that philosophers should train themselves for being like science fiction writers. That's different. They have to try to train their mind in order to be able to think what could be unthinkable. One could express that insight with a statement of a paradox of evolution. Could members of a given species, be it exceptionally smart, like humans, be able to think everything that has to be thought in the universe? To ask the question is partially to answer it. No. Hypothesis that one will see in the hyperfuture. Human philosophers hybridized with machines or with deeply genetically modified brains should be a thought. Of course, it sounds weird, but one has no reason to believe that this is not possible and will never happen. Objections such like the one for which only embodied intelligences and in human bodies, of course, living in human societies could have a philosophical activity, well, still are learned forms of gossip in which one has not to give too much attention. Okay, in conclusion, I think that one used to say that hyperfuture is not knowledgeable compared to near future, but this is not true because hyperfutures could happen as soon as tomorrow, and it's not really a temporal category. 2 points are of interest for the discussion. The first one is that one used to pretend that what is more plausible has more chance to happen, which is the true plausibility for the far away future is a useful-less notion. Second, one has to forget that idea that there is a sense of history that draws humanity in a given already determined direction, like in the perspective that has been proposed by Hegel. What one has to be aware of is to prepare ourselves to extreme situations that one could meet with great probability, but for which one has not yet workable representation. Post-Anthropocene world has no chance to be like what we anticipate, either in good or in bad. This is a true challenge for philosophy, and I have suggested that for this reason, philosophers should learn to think more like science fiction writers than like a positivist thinkers or specialists of interpretations of text. I don't say that that are not interesting activities, but that those activities are not the good ones for what is at stake. Philosophers, and that to think these issues, philosophers have to think about the possibility that philosophy will not be done only by regular human. And I have the dream that in a coming future, such a meeting would meet not only scholars from different countries and different continents, but humans, machines, artificial kinds of intelligence, artificial intelligences, and maybe some non-human biological organisms. I would like very, very much to discuss with a fish. Thank you.
Thank you very much, Dominique Lestel. So I'm going to propose as a sort of antechamber to the discussion to hand back to Professor LeDoux so we can hear a little music, and then we'll start our conversation, if that's okay.
You're muted, Joe.
I'll just, let me just share the screen again. And I'm sure it's going to work now. I figured out what the problem was. Can you hear that? Did you hear anything?
Yes.
We did, yes.
life is to postpone its end. Keep on going and continue to contend. Life depends on adequate subsistence, coexistence, and sustained resistance to. As soon as there is light, there is danger. We think that life's about our precious kind, about our fancy self-conscious mind. That's an illusion, feeble illusion, take a kind of human confusion. As soon as there is light, there is danger. Dreams and self, they struggle for existence, allowing us to hope for persistence. The earth is tough, and she will survive, despite our efforts to control what's alive. As soon as there is light, there is danger. As soon as there is light, there is danger.
So what you just heard is a key change, and the idea is that the songs on this album are all continuous, like life, and there's some morphological change as a new form of life evolves, and that's what the key change is doing, is taking you from one aspect of life to another aspect of life in a different key. Anyway, that's what it's about. Okay, so I guess we can move on to the discussion.
Fabulous. Thank you for sharing that. So yeah, let's start out with some discussion between our panelists, and I think it's best if the two of you pick your sort of points of interaction, but I'm going to suggest two nonetheless. I think in these two great presentations, there are a lot of common themes, common questions, but often quite different positions and approaches, maybe because of discipline and for other reasons. The first point of interaction, I'm really struck by the fact that a professor of neuroscience reaches out to music, not to illustrate, I don't think, but to do thinking, right? You correct me if I'm wrong. And similarly, that a philosopher reaches out to science fiction, which I think is, pointed to the fact that in both your talks, clearly we're facing, some major technical challenges in the future of our climate disaster, but we're also facing a challenge that's levied at our imagination, right? We need to make different uses of our imagination in order to think about things differently. So that was one point of interaction that I thought we might linger on. And the second one, I was really struck by at the end of your two presentations, there was some suggestion of a gathering of sorts. And in the first talk, this idea of a gathering of consciousnesses, or of conscious beings, whereas Dominique Lestel's talk ended with an idea of inviting non-conscious organisms to the table, which I thought was a really interesting opposition, which could probably lead us far in the discussion. So those are a couple of initial possible directions, but also it would be great to sort of hear how you might have other thoughts for possible interactions. So I'll hand over to whichever one of you would like to take the microphone first, and then maybe in about 10 10 or 15 minutes, we'll take some questions from the Q&A.
I have a question for Dominique. So his idea about having a fish on this panel that he was talking about. So you're a philosopher. So Wittgenstein said, you know, if a lion could speak, we wouldn't understand what he was saying. How are you going to understand the fish? You're muted. Sorry, you're muted. Dominique, you're muted.
You know, there is that story of the two Chinese philosophers crossing a river and seeing a fish, and wondering whether they could understand what it means to be a fish. I think that one of the key points is that because of our evolutionary history, we share a lot, even with the fish. And one possibility, interesting and maybe fruitful possibility, could be to try to reactivate what we have in common with the fish, and to try to converge in order to try to feel like a fish, to try to see the world from the point of view of the fish. This is what I mean in a certain way by that idea, that a crazy idea of evolution from the point of view of the first person, and to try to initiate a dialogue with the fish. This is the evolutionary perspective from the point of view of the second person, which is not exactly the same as the first approach. And of course, there are an evolutionary gap, but there is an evolutionary gap between your dog and you, and you can share a lot with your dog. So you could say, well, but my dog is a mammal, and not the fish, which is true. But in which way should it be really an objection to the possibility to converge with a fish and to share a lot? An important point, and which I shall finish with that, is that kind of interactions should not be, to be really fruitful, and that's important for me, should not be an instant interactions, but as to take part in to be part of a long time. I think that more you share with your fish, more you can communicate and you can interact with you. And you can see that with insects. You know, for instance, we used to say that insects are not very complex creatures, but we have in China with some insect. I don't know the word in English. Grillon. They trade these insects for fighting, and they establish a great proximity to this insect. So why not a fish?
So I mean, they appreciate the evolutionary continuity with a fish with us, certainly. My concern with bringing the fish into the conversation is that we're making the fish do what we want, and who knows what kind of impact that is on the fish to put him in a room with a bunch of people talking. So, but more seriously, I read a paper recently about the possible legal rights of cyborgs, and I found that very interesting. I'm wondering how when we bring a cyborg into a meeting like the one you're discussing, what are the limits of what we can expect?
Okay, I think that about the ethical dimension of the cyborg too, there are two things we have to distinguish. The first one is the question to know whether we could have ethical interactions with a cyborg, if it is smart enough, if it has consciousness and stuff like that. Another way to think about the problem is to say that to interact in an ethical way with such a cyborg transforms that cyborg in a more complex agent. In the first situation, because of the capacities of the cyborg, the question is, could we have or not ethical interactions? In the second situation, to have ethical interactions with the cyborg is a way to make the cyborg more complex and agent. It's not something that comes afterward. It's part of the process. And I have a question for you about the difference between fear and danger. Would you say that the notion of danger could be applied to a mountain?
So, I think that I've thought about this a lot because, when I say as soon as there's life, there's danger, but, and I think of danger in a biological sense, but I don't see any real reason why we couldn't think, my only concern with extending it too far is sometimes when you overextend the concept, it loses its meaning. And so, but I certainly believe that, a rock that is degenerating under the forces of nature is, in some metaphorical sense, at least, in danger of not persisting as a physical object.
Why that restriction of metaphor?
Old-fashioned. I don't know. Like I said, I've been mainly concerned with understanding the history of danger in life, but I have thought about it in non-living things, and I'm not completely against it. I think certainly, a human body degenerates over time. That's what life is about, degeneration of the body, basically. And that is certainly true of inorganic material as well. It's just maybe it's a physical principle, of entropy or something.
There is a story I like to tell. It's a story of an American anthropologist. Hallowell was a specialist of Amerindians of the Great Lakes, and he was working in a kind of ethno-science approach, and was interviewing one of his informants. And at once he asked the questions: do you think that a rock is a living agent? And the Amerindian was thinking about that, and after a brief thought, answered them, sometimes it is, sometimes it isn't, which was very disturbing for that anthropologist who think that either you are alive or not, but not sometimes.
Yeah.
Do you think that we could be sometimes alive?
Well, I mean, if you define life as, the ability for your genes and your individuality to keep your organismic system in its state of interacting with the environment for the purpose of persisting, I think we have to, either we're alive or not as an organism. But if you extend idea of life to non-living things, then they're always moving towards. Even living things are always moving towards a final change when not enough of the thing remains to call it a living thing. These are interesting questions. Obviously, we don't have answers.
The point is about non-biological living agents. We have non-biological living agents.
Well, that again, that now we're talking about the semantics of life, and certainly you could have a non-biological. We could have a term non-biological life, and that would mean the way rocks decompose over time. But
so
biological life. Sorry.
Sorry, I'm going to jump in a moment, but finish your sentence.
Okay, the biological life has a certain definition. You might say that that's too narrow, but that's, the question is, do we need a different word if it's a non-biological form of life, or can we extend it at all? Like, I'm not too fond of overextending concepts, since we have such a hard time understanding the more limited concept at this point. That's where, at least scientifically, that's where I think we should be.
Okay, let me tell you another story. A couple of years ago, a judge, an American judge.
Excuse me, Dominique. Just because we have 10 minutes left, could we take a few questions from the Q&A, because there have been questions for the two of you, if you don't mind. Thanks.
Okay.
So I'll start with a question for Professor LeDoux, and then Emilienne will take over. So thank you for presenting today. A wonderful topic and very apropos to where humanity is at this time. Any thoughts about how to apply these ideas to emerging into a post-COVID-19 world, given that many people are in chronic dysregulated states of fear?
Yeah, so we are, the world has definitely changed over the past year. And, it's been said that every generation since Auden's poem, The Age of Anxiety, has claimed to be the most anxious age. And I certainly see that in my students who think they're more anxious than the group of students were 2 years ago. I don't mean post-COVID, I just mean in general, students always think they're more anxious than their predecessors. But, and can we say that we're more anxious now than people who were living during the Spanish flu were anxious? Or what about the people living in the Middle Ages, serfs outside of a castle? They must have had a terrible life and some misery in the cold and lack of food, and their life couldn't have been, quote, very happy. They maybe were content in some kind of sense of what they had. So, but in terms of how the fact is, we do have a kind of, in our lifetime situation where the amount of fear and anxiety is very high right now. And, my way of thinking about this, if I'm right that fear is a personal interpretation of the situation you're in, then we have to find ways to help people reinterpret that situation and help them cope with the body changes as well as the psychological changes that they're experiencing. So I'm always hopeful in these situations that we can find a solution if we put our minds to it. And that, like with the climate, we can say, well, it's so bad now that we should, let's just have fun and forget about the climate while we have it, just use it while we have it. But I think we really do need to do something, and we would be foolish to just let it happen because we all want our children to survive and their children to survive. So.
Thank you. Emilienne, go ahead.
I have a question that's been addressed to both speakers. In light of what has been discussed about species and creation of life, do you think that embodied agents like social robots could be effectively integrated in our society as a new species on their own? So maybe we can start with Dominique and then Joseph LeDoux.
Thank you for asking the questions. That the topic of the book of my book that has just been published by Fayard about machines insurrectional machines, and I think that yes, the answer is definitively yes. We will have. I will not tell social machines, but existential machines. Yes, and we already have artifacts like that. If you think about some puppets, some teddy bears, some artifacts like that, they already are part of our societies, of our social connections, and so on.
Joe?
I'm kind of neutral on cyborgs again, because I feel I have so many problems understanding living things in the biological sense. I'm not opposed to it. I think, certainly the AI is really fascinating topic. I look forward to reading Dominique's book and getting it as soon as possible. So maybe I'm not really that well educated on the topic, so I don't want to say things I don't know too much about. But I'm going to read Dominique's book, and then next Earth Day we can come back and talk about it. So
let me ask another sort of big picture question that's come in. I agree that humans need to act, but there are many views on what is needed, all of them with large uncertainties. How do we move through those uncertainties? And maybe, the fact that Dominique Lestel presented different versions of a future, maybe that's a place to start. Dominique, would you like to start, or Joe?
Well, there are many ways to be confronted to uncertainties. But we used to, the point is that we used to think that we could be out of the action of uncertainties. And we have to think that uncertainties, and I mean big uncertainties, not shallow ones, not superficial ones. We have to make ourselves able to think that big uncertainties, even uncertainties we do not have seen as such, could happen, and very quickly. And we have to try to make sense of that in our life. And most of us would say, well, I know what tomorrow will be. I also know what next year will be. Well, in 10 years, maybe it's more difficult, but that's nonsense. We don't know what will happen in 2 hours. And we have to try to train ourselves to think that almost everything could happen. And when I say almost everything, I just say things we do not think about.
Joe, would you like to address that question?
No, I don't think I have anything to say.
Emilienne, do you want to ask the next one? Or?
I have a question here, and I think it probably will be the last to you, Joe. Professor LeDoux, thank you for the fascinating talk. According to the view exposed about danger, threat, fear, and cognition and metacognition, would you agree with some claims derived from the research of Stefano Mancuso on plant cognition, based mostly on the fact or the idea that plants have a molecular alarm signal? For example, the claim that plants would have some sort of cognitive self-awareness different from the one of animals, so to speak.
So again, we're talking about semantics as to how we define cognition. Plants have some amazing behavioral capacities. They're able to process information that when their roots are extending and the territory they're extending in is relatively dry, they are able to sense where there may be more moisture and they move in that direction. It's all very complicated, but is that cognition in terms of forming an internal mental map of a situation and making a decision independent of existing stimuli on the basis of stored internal representations? I mean, that's how I define cognition, but that's an arbitrary definition. And you can extend cognition into all of life. You could say bacteria have cognition, and some have claimed that as well. So I think we agree on the what we see in the bacteria and what we see in the plant. It's just a matter of what we call it, and whether extending the word cognition or consciousness or any other word beyond some rather narrow confines of that limit what it means. If, for example, when we extend consciousness into the universe, okay, you can say that on the basis of some scientific principles, but that doesn't mean that my conscious feelings about what's happening in my life is the same thing as what's happening in some quark in outer space. It's a different thing, and so we have problems. We have boundaries that scientifically are useful to draw because it sets up limits in order to explain things, but it may cut some things short in terms of making the explanation broader. But if we start too broad, then we only end up arguing about things that aren't the same thing. So I like to keep things relatively confined.
Thank you. So Emilienne, I think we're more or less out of time. So I'll start by thanking our speakers for really interesting interventions, and I think the conversation could carry on for much longer. So thank you, first of all. And Emilienne, do you know what the next issue in the series is?
Yes, very probably it will be on June 17th, which is the International Day Against Drought and Desertification. And I'll keep everybody posted on that news. I would like to thank the three of you. I'd like to thank you, Philip, for the points you made about the connection with art. I've known Joe for a long time, and his music definitely is part of his circuits, and a very important way of dealing with life and what it brings us. Dominique, I'd like to thank you very much as well for your very thought-provoking and sometimes disturbing images of the fish at the table, but not in the common sense of the term. So I think a lot of us will be thinking about that. Once again, Philip, thank you for being the moderator. And I'd like to thank NYU in general for this wonderful partnership, as well as, of course, my colleagues at PSL. Thank you.
Thank you all as well.
Thank you, Emilienne. Thank you, everybody. Thank you for coming.
Thank you. Bye.